And so our first speaker today is from the library at the University of Basel, who's going to talk about their workflow for archiving digitized historic books. And that's Jürgen Enger. So if you're ready, Jürgen, can I pass the control to you? Thank you. I can see you're sharing your script. There it is. I can see your first slide
Hey, thank
and
you
can hear you.
thank you very much for the invitation. Yeah, I want to show our workflow from our historical book to the digital archive, but I want to focus mainly on our archiving workflows. So as an introduction, I will show how our workflows are starting, and then I will go into our, I call it OCFL workflow, where we put all our digitized materials into the OCFL native archive. So what archival content do we have? We have standard content, which is available at libraries, books, newspapers, sheet music, flyers, large image collections, some time-based media. And since I'm talking about books, we have about 300,000 digitized books, 4 million pages, and the books have about 300 terabytes of data. So how does it happen? Initial step is we are cataloging. Cataloging for a library means normally that you catalog into a library catalog. In our case, it's Alma from Ex Libris. Then we have our digitization stations. They generate high quality TIFF files and is using a workflow system called OBI. But this is not a very fast process. So if we want to be faster, we just get a truck and send everything to Google, and they do it for us. So much more performance, but less quality. For our internal workflow, we are using a software called Visual Library, which has a server and a manager, which is maintained by another university in Zurich. So we are sending all our TIFF files, including the metadata from our library catalog, to Zurich, where it will be arranged from our people to make chapters and so on, and generates OCR stuff. All this is in the end packed together into a zip capsule, and we get back our TIFF files accompanied with metadata, which contains all the structures of the book and so. Google is a bit easier because Google just gives us some metadata, which is not as large as the metadata we are generating with the visual library, and sends us JPEG 2000 files, which have a bit lower quality than the self-digitized ones. What we have to think about is that all these processes contain updates. So we can never say we are done. It can happen at any time that we get new versions of metadata or of digitized images. This makes it a bit complicated. So what do we have after this initial step of digitization? We have TIFF files, we have JPEG 2000 files, we have structural metadata from Google and from library manager, and we have metadata from our library catalog. So metadata and especially TIFF files we send to our so-called media server. The ingest does a quite exhaustive technical metadata recognition, and then we have all our media files in this server. This server, just a short view on it, gives us the possibility to display audio and video files. We can show PDFs. We can have a Zoom, IIIF Zoom API, And we can get all our metadata, which gives us quite much information about the technical content. Additionally, we have live transcoding for images, which means we can transform formats, we can resize, we can crop, we can do whatever we need for our front ends. So that's what our media server does. Additionally, all this metadata is sent into a license service, and this license server tries to extract from the metadata to know what license has this file. We don't want to have anything in our archive without a license. So if it's Creative Commons, we are happy. If not, we want to know which license it is. And if we really don't know, we really want to know that we know it, that we don't know, so we don't have any object where just nobody has thought about what it means. So after these two services, we have two more metadata sources, the technical metadata and the license metadata. In the next step, we have all this metadata and we are using a tool which is called Alma to Elastic. This takes the metadata from our library catalog system and enriches it with all the other metadata we have collected so far. And all this we put in a full text index in Elasticsearch index. So together with the media files, which are inside of the media server, we are now able to send it, for example, to our data viewers. So this is done by a middleware which allows exhaustive searches over all these metadata objects and brings in AI stuff and so on. But this is not what I want to talk about. So our archival ingest uses the same sources. So this means for our catalogs and for the archive, we have up to this point the same workflow which is used. And this is quite helpful because we don't have to maintain different software services for different target systems. So our archive system will start with an ingester, which takes all metadata and puts it together with the image files, with other transcriptions, OCR files into a file structure. So we have in our archive all metadata we know about. And this is quite necessary because we know that if we just store the images and nobody knows where they belong to, it's not a really good thing. So all our metadata with license information is archived, and we are archiving it. And this is somehow special because we have developed our own archive system and our own archive packager. And as you can see, it's focused on OCFL. And this means that we rely on a not so old file layout, which is used by more and more archive systems. For example, it's used by Fedora repository. Zenodo is quite active in this scene. And it's a file layout which which gives us a possibility of completeness, parsability, and so on. You can look at the website. But one thing we really love is that it's extensible. So you don't have just what's written there. You can create your own extensions and enhance the OCFL system with it. So our OCFL workflow, I want to just show something about OCFL. If you're not familiar with it, it's good to see that OCFL's main file and metadata is the so-called inventory. The inventory has just metadata like the ID, It gives us a digest algorithm, and the core element of OCFL inventory is the so-called manifest. The manifest is based on the idea that file names are just labels. So there's no need to reference to a file with a name because we reference to it with the checksum, which is defined here. So same file has same checksum, can have different labels like file names. So here we have one file, which is 3 times inside of the archive. This is clearly a candidate for deduplication. Furthermore, we have these so-called versions. Every version has a state which describes how the files look like outside the archive. So here you can see it's inside, and here we have the name which is outside the archive. And again, it's referenced by the content, especially with the checksum. Additionally, every version has a date, a message, and the user who has created this version. Here's an example of a version 2. So in this case, we have, for example, moved the file from this name to a subfolder, and this means file movements just mean give it a new label. If you extract it, it will appear at a new folder structure with a new name, or just don't mention it, then it's deleted, or give it, or whatever you want to do, you can duplicate it and so on. So this is what OCFL natively offers. If you need more checksums, there's a fixity part. This is quite necessary if you, for example, move from an old archive with different checksums. You can just put it there, and then you can compare whether you have all data moved into your archive. So back to our OCFL or GoCFL tool. So what does this tool, that's the packager. It's actually a command line tool which implements a number of OCFL extensions. So it takes what the ingester has generated, the file structure, and then it does several steps to enhance the package. To do this, it's highly parallel, so it tries to read every file only once, and it writes every file only once. But in between, we have format recognition, for example, which means that we are using Siegfried, which is quite a common tool for getting nomes and MIME types, TCAR for recognition of office formats, FFmpeg and ImageMagick for time-based media and images. And then we get our information. It's the same tool we are using in Media Server. So technical metadata recognition is duplicated somehow. Since many people think you have to have METs and you have to have premise, we have an extension which generates METs and premise, and it uses DILSYS EARC AIP format, which is mostly implemented, but there are some pieces which are not possible because they are not compatible with OCFL. We are trying to rename our file names if they are ugly. So this is really necessary and, oh, sorry, I'm too fast. We have file system metadata. File system metadata is not so necessary for digitized books, but if you have estates, for example, you want to know from which disk does it come from, who has which rights, and so we have also native data from the original disk in our archive. We are renaming names. To do this, for example, we are replacing blanks. We do not allow, in this case, tilde characters at the beginning of file names. We remove leading and ending blanks. And this is a registered extension. OCFL has registered and not registered extensions. The registered one are officially reviewed by the OCFL team, and this is an extension which has been reviewed, but which has been implemented by us. The others are not yet registered. To make it better looking, we generate thumbnails. Here we have a thumbnail for an audio file, which is spectrogram, which looks quite nice. We have frame shots from videos, smaller images, and so on. And we have migration. Migration means that within the initial process, we can define migration rules based on the pronoun IDs. So in this example, we have a PDF file which comes from an encapsulated PostScript file. And while interesting, we just generate a new version. Here you can see why we need these versions in OCFL. So we have a migrated version of our encapsulated PostScript file in a new version in the OCFL. And this is already in the standard. So we don't need any additional functionalities from the archival system. It's just inside and everybody can understand it. And then we can use it with different tools. So this object can be moved from one archive to another. Since we want to have in our archive system some metadata, we have an extension which deals with our basic metadata, which is used for our archive database where we can research. Especially in the library, we have many identifiers for the same work. And quite often people come and search for a specific identifier and want to know, do you have this in the archive? So identifier is quite necessary. Additionally, we have a collection and we have an organization because our archival system is multi-tenant capable and therefore we have to know who's the owner, which collection is it. We want to know who's the archivist and all these other things we're just writing in this basic metadata file, which is maintained by an extension. Then we need reporting. We are not yet in the archive, we're just in the SIP or AIP, so it's a bit mixed in our place, and we can report. Report consists of a technical front page, which says who has archived when and what. We have a semantic page, which comes from our basic metadata. We can see which MIME types we have, which pronoun IDs we have, file structure. And here we can see why we need our thumbnails. So it's quite nice looking overview what's inside of our archival object. This is quite usable for research data because it can be attached to a report of a research project directly. And it says, hey, I have a good data object and you can see what's inside. Additionally, we can extract metadata, not only the inventory metadata, but a combined metadata file which contains all the content from the extensions. This is used later for our integration into the archive. So I just mentioned SIP, AIP, and DIP. So actually we are talking about SIP, AIP because in our case it's a combined thing. The visualization means our tool can display web pages which contain the same information than the report, a bit more exhaustive. We have an overview with statistics. We can look at the manifest and we get some technical metadata. In the version metadata, we have technical metadata and file system metadata. We can see different versions and we can get detailed view on similar file, on specific files. So we take this file, we extract the metadata, push it into our archive, where we have a storage handler, And we have our self-contained AIP now. We put it on a storage. We write it into a database. Here we have a dispatcher which takes care that every object has enough copies. So we know about costs of storage locations. We know about quality and can give every collection a specific target quality, and the dispatcher figures out what's the cheapest or yeah, way to store with a specific quality. And we have a checker. It's a microservice architecture, which is completely cloud-based, and we are only using cloud-based storage. So actually it's S3, and you can buy your storage wherever you want. Every tenant brings in its own storage, but we have a central management we are using. And we have a small GUI where you can search around, see which collections we have, get some statistics on collection level before we saw the statistics on package level. Yeah, we can see the packages. You can even see where the packages are. You can even search the files, and you can get a reporting. So this report is a yearly report, for example, which gives to every collection owner what they have stored, how many storage they need, and so on. So the last two things, the whole archive system and the packager is completely reprogrammed to make it easier to understand, because we felt that current archive systems are quite complicated, and it's not good for quality management if you don't understand your archive anymore. And therefore, we simplified it and pushed it into a cloud technology. So thank you very much for your attention. I hope it was not much too long.
No, thanks, Jürgen. That was excellent and very good timekeeping there. Um, so, uh, just seeing if there's any questions coming into the chat. I can see about uh, Mary has just put in Mary Costa's put in something about being able to keep track of your costs, and I think that's a crucial step. So, whilst people are perhaps having a little thought, can I ask? So, is GoCFL this tool you've written? Have you shared it? Is it made available via GitHub, or can other people
Yeah,
take it up and use it?
yeah, you can actually see the
So this
URL,
is the
but
URL here. Yeah.
yeah, but it's not yet exhaustive documented, but it's usable, and you can reach out to us if you have any questions. So as the archive is there too, but not yet completely documented.
Okay. Thank you. So Christopher's come in with a question about. He said, "What are you doing for fixity validation?"
Um, there's a big problem with object store like S3 and many files. This means we are not using flat OCFL objects, we're using zip files. So in this case, we have a checksum. When you create your zip file, you put into the object store, we just generate a checksum, and this checksum is checked every year, for example. If we would put the OCFL flat, GoCFL would generate all checksums in the fixity and the core area of the manifest concurrently. So it reads the complete all files once and generates checksums against the manifest, and then you know whether it's valid or not. So it's a concurrent process, but too many files are not so good in object storages actually. But next version of OCFL will take care of this problem, and then we will have something like packaged versions, which will really be helpful.
Thanks, Jürgen. I guess Christopher will say whether that's what he needed to know, but whilst he's thinking, can I ask you, you talked at one point about sort of automatically recognizing formats and taking certain actions on that
Yeah,
basis. So what? But I also noticed you had a little group a little line where it said the file format was unrecognized. So what happens with that material?
No, the unrecognized file formats are the generated ones. So if
Okay.
you ingest, quite often you generate like the mets and premise stuff, and this does not go through this process due to performance reasons, because we're generating without storing it. The main
Okay.
problem is that in archive context, we buy cheap storage, which means we buy slow storage, and therefore we want to minimize I/O.
Okay.
So that's a drawback. But
Okay.
most things we can recognize. We have some problems recognizing which XML dialect and so on. So this is quite hard. Some we recognize, some we don't recognize.
Okay. And then my last question was about you talked about having different versions in the archive in the repository. So do you do anything with the different versions? Do you sort of delete them eventually, or do you hold every version of every object that you've had, or what?
In the actual OCFL release, deletion is not intended. So it says you archive, you have it, you keep it. Deletion only means do not extract it. In
Okay.
the future OCFL versions, there will be a possibility to delete, but you should not. So if we get a new version of a TIFF file, I think we will keep the older version as long as we have enough money for the storage. So that's the point we will think about deletion will be mainly if it becomes too expensive.
Okay. And in fact, your comment there has given me one more thought that I know a colleague of mine would want to ask. So you talked about the tool being able to monitor your storage costs and keep track and go for the
Yeah,
cheapest storage. Is that purely the financial cost, or does it also take into account things like carbon footprint and environmental impact? Do you rate the different storage options in those ways as well?
actually we have two qualifiers. One is the storage quality, which says how good is it, do I
Hmm.
trust it, and the other is the price. Both are not really, price is not really only about money. Price
Okay.
could bring this in. So, but it's quite hard to determine this. But if you say, okay, that's cheap but bad for environment, then you can just enhance the price and it will adjust accordingly.
Thank you. That's good. Yeah. I'm going to stop inflicting my questions on you. I can't see anything else coming in through the chat. So can I just ask everyone to give Jürgen a quick round of virtual applause? If you can find that, the clapping hands under the reaction button down at the bottom, that would be great. Thank you, Jürgen. That was wonderful. And so
Thank you
next,
very much.